Hey guys, my name is Chandan Sahu and I have built a new analytics project, Payment Transaction Analytics Platform. Let's look at it. Honestly, the hard part of payment analytics was never the SQL. It's getting fraud, finance and operations to actually agree on one number. So that's what I built this project around. 500,000 synthetic transactions modeled on how Indian payment rails actually behave, all flowing into one source everyone can trust. The setup follows a pretty standard ELT pattern. Python generates raw CSVs, a watermark-based script loads them into PostgreSQL incrementally, and dbt handles all three transformation layers. There's a Python script that builds the reporting schema. The synthetic data is not just random noise. I designed it to actually behave like real anomaly patterns, so the fraud probability for a user spikes based on 4 signals: odd-hour transactions between 1 and 5 am, high-risk categories like travel and electronics, ticket sizes above 12,000 rupees, and sudden jumps in velocity compared to that user's own history. On the ingestion side, there is no full table rewrites happening. The watermark just reads the last loaded timestamp, pulls in only the new records from the CSV, loads them in chunks of 10,000 rows, and commits the watermark update in a single transaction. So it's incremental, it's idempotent, and we can rerun it safely without ever double loading the data. Staging keeps things clean and fast, casting columns, pulling out hour and day of week, flagging early indicators, and all the thresholds live as dbt variables, not hard-coded numbers, so they are easy to tune later. The real work happens in the intermediate layer. Window functions calculate per user transaction velocity over both 1 hour and 24-hour windows. And then a weighted scoring model builds a fraud risk score from 0 to 100 off from that. What comes out the other end is a risk tier, anywhere from low to critical, plus a human readable reason field. So something like odd hour, high amount, which makes it actually usable for human reviewing, not just a number. There are 3 marts which I want to walk through, and each one came from a deliberate design decision. First, merchant risk. Think about it as a merchant with 2 transactions and one fraud shows up as 50% fraud rate. That's just noise, not a real signal. So each rate reliable flags require at least 50 transactions before a fraud rate even gets surfaced. Below that, it just returns null. That way, risk teams are only ever looking at statistically valid targets, not false alarms. Second, velocity anomaly detection. If a user hits 5 or more transactions in an hour or 15 plus in a day, they get scored and flagged with action required set to true. Basically, a prioritized work list for the operations team. And third, fraud customer segments. This is RFM segmentation with a fraud dimension layered on. Clean, single fraud, and repeat fraudster. So marketing team can go run win-back campaigns on lapsed customers who are actually clean while automatically screening out anyone flagged. There's 2 layers of quality checks here. PyTest handles the ingestion side, CSV shapes, schema types, making sure the database connection actually works. And then dbt adds 81 schema assertions on top of that across the whole warehouse. Primary key uniqueness, foreign key integrity, valid values for things like status and payment method. Prefect ties all of it into a single automated flow. Container startup, generation, pytest, dbt build, warehouse tests, all of it. And that same flow kicks off automatically on every push through GitHub actions. So there's no manual steps sitting in the pipeline. Here, page 1 shows the executive overview. 3.4 billion rupees in GMV, a 92.6% success rate, and about 88 million rupees has been lost to fraud. Page 2 shows success rates that come out nearly identical across UPI, cards, wallets, and net banking, all sitting around 92.6%. So the failure problem clearly is not about payment method, it's happening somewhere else, maybe on the merchant side or timing related. Page 3 shows fraud heat map. Hour of day against merchant category. Electronics at 2 am hits an 8.3% fraud rate, travel at 2 am hits 7.5%. Off hours overall run at 4.2% fraud rate versus a 3.5% platform average fraud rate. Page 4 shows 2 charts side by side. One ranks merchants by fraud rate and the other by total loss. Biswas PLC, for example, comes in 10th by rate, but first by total loss. If we only had one of these views, a risk team would misrank their entire priority list. Page 5 shows customer segments, whereas page 6 shows velocity alerts. And finally, the recommendation page shows business recommendations and data limitations. The project is publicly available on GitHub. Please do check out. Thanks for watching.